Hi, my name is Jackie.
Hey, I'm Joe.
When we aren't busy, we like to be detectives.
Our case today is one that runs close to home.
As you can tell, we're identical twins.
We look the same and we were born at the same time, so people assume everything else about us is the same.
But is it really?
Epigenetics can answer our question, so let's look into it.
Our cells contain genetic material called DNA. DNA is made up of strings of nucleotides, which are made of 3 components: simple sugar, a phosphate group, and 4 nitrogen bases: adenine, thymine, cytosine, and guanine.
These 3 components put together create the double helix ladder shape DNA is known by. DNA is loosely wrapped around a protein called histone. When DNA is in this form, it is called chromatin.
The chromatin contains genes which are like the instruction manual for the nucleus. One gene or section of DNA might give you blue eyes, while another gene might give you blue skin.
As Jackie said earlier, genes are like an instruction manual. It has to be read so the gene knows what to do. The process to read a gene is called transcription.
During transcription, a DNA polymerase reads the gene and translates the gene into a protein called mRNA.
However, the cell still does not understand what mRNA is saying, so a protein called RNA translates the mRNA into a language the cell can use to do its function.
That's a brief intro of genetics.
Hey, Jackie, do you see this?
What is it?
I think it may be the next clue to solve the puzzle.
Clue number 1, epi, means on top of a gene.
So what does that mean?
Wait, who's that guy staring at us?
He's running into a lab. After him.
It's a tag!
Looks like you have found your second clue. The tag represents your epigenetic tag. An epigenetic tag can be turned on or off. For it to be switched off, the tag forces the histone to keep the DNA coiled tightly, not allowing it to be read or expressed. To be switched on, the DNA must be unraveled from the histone. This allows for the gene to be read and expressed. There are 3 forms of epigenetic tags: microRNA, DNA methylation, and histone acetylation and deacetylation. In microRNA, translation occurs when the mRNA is translated into protein, a language a cell can use. The RNA is supposed to perform the function. However, sometimes another protein called microRNA comes in and attacks the RNA, dragging it away so the translation never occurs. This silences the gene because it was never translated into a language the cell could express. DNA methylation is the second type of epigenetic tag. In this tag, a methyl group attaches to the top of the DNA, usually by adding a carbon to the cytosine. This makes the DNA polymerase unable to read the gene, because it's not in the language the polymerase could read. This leads for the gene to be silent and not expressed. The third type of epigenetic tag is the histone acetylation, which occurs when the acetyl group is added on top of the DNA. Like methylation, the acetyl group decreases the affinity or the attraction between the histone and the DNA. The decreased affinity allows the DNA to be unraveled and to be read. In histone deacetylation, the opposite occurs. An enzyme removes the acetyl group, causing the histone to tighten the DNA around itself even more. Deacetylation is said to be an agent in causing cancer. A cell called p53 inhibits the abnormal cell growth. However, when histone deacetylation occurs, the gene is switched off. This results in a triggering of abnormal cell growth, which is also known as cancer.
Wow, so what can cause these epigenetic tags?
This ties us to nature versus nurture. Nature is what we inherit from our parents, for example, our hair and eye color. Nurture is when the environment plays a factor in the expression of our genes. In truth, both nature and nurture play a significant role in our genetics. An individual's environment can play a factor on their genes. Things like smoking, drug use, diet, exercise can all impact our gene expression. This can cause a change in gene expression, which can be passed on to our children.
Wow, we really are unique.
Mystery solved.
Our choices of today can affect the genetics of tomorrow.